Percent proportion applications. In order to do a percent proportion application problem, you have to be able to identify what is the part and what is the whole. So instead of looking at your proportion through using the words is and of, those aren't always as noticeable. So instead, what you want to do is you want to approach it through the idea of what is the part and what is the whole. So when we talk about part, one of the things that we are leaning towards is that you should be thinking about the percentage, or part being the small piece or small part of it. The whole is where you're thinking about the total or your overall idea. We are still going to use our proportion formula, so we still have percent over 100 is amount over base. But instead, when we think about it through our new terms, we're thinking of it as part over total is to part over whole. Okay? And so what we have to do is we have to be able to read your problems, and then from reading your problems, you then would do, or you would decide which is which part and which is the whole, and then from there you also have to look at what is missing. So we've got a couple examples that I want to do to show you different ways of being able to attack these problems where your missing variable is different pieces of the puzzle. So here we have in 2016 the Los Angeles Dodgers led the major leagues in home attendance, drawing an average of 45,720 fans to the home games. The figure represents 81.64% of the capacity of the Dodger Stadium. Estimate how many fans the stadium can hold to the nearest 10 when it's filled to capacity. So when we're talking about nearest 10, we are actually talking about a whole number, not the decimal. Okay? So we have to look at what do we have. Well, first, we're told that your percent is 81.64. We are also told then that your part is 45,720, which means your base, or your whole idea, is the part that is missing. So we need to plug our information in. So we're going to have the 81.64% over 100 is equal to 45,720 over B. So the piece that's missing is the whole. So now we need to solve. So we're going to have 81.64 B is equal to 100 times my 45,720. So to find my B says that I have to multiply this out, so I'm going to have my 100 times 45,720, and I have to divide that by 81.64. So let's look at the fastest way to do that inside a calculator. So here is a basic calculator. What you want to do is to multiply the top first. So 45,720 times your 100 and hit equals. Then divide by the bottom, 81.64, and hit enter. Now notice we have a pretty lengthy decimal here. So the first thing that we're going to do is we're going to write out the whole number, so 56 and 1. But then we're going to write out a little bit of the decimal, so 9.5. Now the reason why I don't care about most of it is because I want the nearest 10, which is the whole number. So the nearest tens place, if you remember, our whole numbers go ones, tens, hundreds, thousands, etc. So the tens spot that we're looking at is this place right here. which means we have to use the spot next to it in order to determine your rounding. So we're going to look at this 1. Since 1 is less than 5, it means we round down. So here we actually have that your stadium holds a capacity of 56,000 people. And this would be the result that we are looking for. Alright, so let's go ahead and do it again. So we have, within the borders of West Virginia, the length of Interstate 77 is 186 miles. Of this, 88 miles is a toll road. What percentage of the interstate in West Virginia is a toll road? Round your answer to the nearest hundredth of a percent. So here, what exactly do we know? Well, we know that my total is 186 miles. I know that my part is 88 miles. What's missing is the percent. So here we're going to end up with P over 100 is equal to 88 over 186. Solve for P. Says P is equal to 88 times 100 over 186. Now, the way I was able to do that is P is on top here, so if I multiply the whole thing by 100, my 100 goes away and puts it on the other side. So that is a shortcut way that you can use to work with your proportions. So essentially what it means that we did is we just simply did the cross product in the one direction. Okay. So now, doing that, we would have 88 times 100 and divide that by 186. So here we're going to end up with P is equal to, and again, here we go. So we have 88 times 100, divide that by 186, and we get 47.3118. Now I want the nearest hundredths place. My hundredths place is going to be this second place right here. So to use that means I have to use the spot right next to it. Because 1 is less than 5, that means my P is going to be 47.31%. Alright, let's look at one last one. In one season of basketball, a basketball player missed 15% of her free throws. How many free throws did she attempt if she made 136? So we have to look again at what we have. So here we know my percent is going to be 15%. And my total is 136, so that means my A is missing. So here we set it up, 15 over 100, because that's my percent, is equal to A over my 136. Again, we could shortcut it by just simply doing the cross product between these two. So this becomes 15 times 136 all over 100 is going to give me my A value. And so here we would go ahead again. 15 times 136 equals, divide that by 100, and we end up with 20.4 equals A. Now, let's think about this logically. Can I throw part of a free throw? Well, that answer is no. So therefore, A would be 20 free throws. Okay, in this case, we would end up rounding down to the nearest free throw, because you can't just throw a part. There's no way that I could stand there and I could throw a basketball and have it only go, I don't even know how I would do that. Have it only go a part of the way and then just simply vertically drop down. I mean, it just doesn't even make sense. If you throw it, then you throw it. So here, we would round down to the nearest. Okay? And so there you go. Those are 3 different examples where your missing term was in 3 different places. If you have any questions about solving percent probability application problems, please let me know. Otherwise, be sure to keep smiling, have tons of fun with your math, enjoy the rest of your day, and I will see you next time.